Well, thanks, sir. I really appreciate the introduction, and it is truly a great opportunity to be here with this robust group. As Dr. Nielsen talked, it is a shame that we are not able to get together and be present, because it is really critical to the collaborative work that we're doing and also building the relationships across this community of interest. But it also is great that we're able to join from all reaches of really the United States and the globe, and how we can come together, and where we may not have been able to travel, we can participate in these types of events and share in this community of interest, and then continue to push forward the work that has been done within AADL and ACVIP, and then really how that fits into the larger mosaic of what the Army is doing and really what we're doing on modular open systems approaches. And so as you look at this, the first slide that I have, and you see this establishing an operationalized MOSA approach, you may say, okay, well, what exactly do you mean by that? And really, it goes back to my background. And as was mentioned earlier, I've moved through a lot of different communities. And before I came here to the PEO, I was actually over in it was called then the MRDEC. And many of the things that are going on within model-based design, digital engineering, and then architecture-centric virtual integration were started when I was there under Dr. Lewis and working with Alex Boydston. And so my thoughts have always turned to, how do we take the science and technology efforts, the developmental efforts that are going on, and how do we actually put those into a production environment or an operationalized environment, so that from an acquisition perspective and from a business perspective, we can execute, leveraging the work that's been done in the S&T community, and then be able to field that out to soldiers, the Army, and give the Army an increased capability. And so that's really what I'm going to talk about today. I'm going to talk a little bit about our journey. And I think, as everybody knows, you always reuse somebody else's slides. So I've got a few of Alex's and old Dr. Lewis slides in here, because I thought those were important to really just talk about where we came from, and the fact that it isn't just something that exists within the Army science and technology community, but it's something that exists within the totality of Army aviation and Army aviation acquisition. But before I get into a little bit of that, I am going to talk about where Army aviation is going and our modernization plans, as I think that's important as part of really setting the stage of why modular open systems approaches and architecture are absolutely so critical to our path forward. So with that, a nice busy slide, but rather than show you organizational charts and as I like to call them, kind of the mugshots and wiring diagrams that government organizations love to show, I really wanted to show where we're going from a future force, the aviation enablers, and the enduring force. And so as you look across the top and you look at the scope of what PEO Aviation does, and really what my boss, I work for Brigadier General Rob Berry, he is the PEO, the Program Executive Officer, is the scope goes from small range reconnaissance, which is really those small UASs, and what we're doing in conjunction with OSD. If you think about quadcopters and how we rebuild the US industrial base, and how we have quadcopter-like technology that is out there through air-launched effects, which would essentially be loitering drones that can go out and, working in a collaborative fashion, go out and detect, identify, locate, report, or create other effects, through kind of the mid-size of future tactical UAS, and where we want to go with our unmanned systems up to the Class 3 level, which is really where we meld to the Air Force, and the Air Force takes over on the larger unmanned systems. And then you look at the manned platforms that are over on the right, which is the Future Attack Reconnaissance Aircraft and the Future Long-Range Assault Aircraft, which are both modernization programs that are ongoing right now. And so when you see that, you can see an aggressive modernization plan that the Army has in order to move from really that enabling force that you see down at the bottom, or the enduring force that we have, and then how that transitions into the future force. And so then underneath that, you have these aviation enablers. And as you look at them on the left, propulsion, electricity, communications, and then as we transition to the right, you can see where we've got into assured PNT, how we look at commonality across hybrid electric and how we generate power for these systems. And then MOSA, and really what we're referring to is really this aviation mission common server approach, or how we have common mission processing and a common environment. And when I say common, I'm not necessarily talking about the same hardware, but the same design approach, the reuse of software, the architectures, and how that actually bridges between that future force of what we're building and then the enduring force. Because the one thing that we have in Army Aviation that, I know there are Air Force and Navy veterans on there from the air side. Our challenge is scale. We have over 5,000 rotary wing and fixed wing aircraft that we sustain. And so when we look at modernizing, we know that a lot of our enduring platforms will be around for decades to come. And so how do we find technologies and how do we apply open systems in a measured form to our enduring fleet that also are key and part of the digital backbone that we're putting into our future fleet? So with that as a little bit of a stage setter and to talk to you about where Army Aviation is going as part of the Army Aviation strategy, I'm now going to dig down into a little bit more of really the architecture and more specifics about what you're doing and how we are really aligned with the S&T community. And so as I said, reusing slides is important. So Alex sent this to me as we were preparing for this. And I thought it was a great refresher of where we're going with Army Aviation and the fact that while the S&T community has used this slide, I will tell you that it's wholly appropriate for PEO and for the acquisition community to use this as well. Because as you see yesterday and you see those enduring platforms on the left, our goal, our objective, and where we are moving is to that government open architecture, both hardware and software portability that you see, how we have strategic reuse, the use of a model-based digital engineering approach, and then how AADL and ACVIP, along with SysML and some other design tools or those digital tools that we have, the digital tool chain, are vital as we look at how we do embedded systems, and then really how we look at opportunity. Whether you see on the right, you see aviation mission systems, which clearly is an area where we want to target first, but we also believe that there is commonality that we can go after for platform assets, as well as electrical systems as we continue to mature our open system approaches. And just the example that I would use is just power management. When you get into power management between aircraft is very similar. As we get into smart power management, how do we go from mission systems and then merge that into how we would do something like smart power management for our aviation platforms as we move to the future? So really all encompassing, but our first target is really on the mission system side of the house, because that's where we see the ability to leverage across many, many different platforms and really shift the paradigm from where it is platform focused. I'm an Apache, a Chinook, a Blackhawk, a FAR, or a FLRAA, and it is rather how do we have commonality in the way that we have our data models that are associated with it, how we look at our architecture, digital backbone, and then specifically into the software architecture, and we ensure that we have the right design coherence between all of that work. So if you go to this next slide, and again, this is a really busy slide, and I will not talk all through this, but I wanted to include it in here because again, this is one that Alex had provided to me. And it's really the S&T's take on how from the left-hand side, we're working on a reference architecture using a digital approach, right? A model-based approach using the design language SysML. And what the PEO has gone all in on is CATIA. And so rather than have many different software tools that are out there, our approach is to work our requirements in CATIA. And then in flowing that out, how does that flow out into an objective architecture that is used at the FVL family of systems? And really the PEO at our level, which is across all of the project offices, all of the platforms and enablers, is how do we orchestrate and govern that family of systems reference architecture that we expect to be used across all of the platforms. And then underneath that, you see this utility family of systems. So now underneath the top level architecture, that is really what is, I'm going to say, the major system components across our open system approach and our architecture, what are those unique that are part of, if you will, if you think in like a face construct, the platform services segment? What are unique to the platform that really have to be called out into a unique reference architecture that is specified for that utility family of systems, or if it is the attack family of systems? And while I've been talking manned, also how does that translate into the unmanned side of the house as well? Because we expect this approach to transition between future and the enduring fleet that we have right now. We want it to transition between manned and unmanned. And then we also have scalability so that as we deal with size, weight, and power issues, we can also address how we tailor that for some of our smaller platforms and those that we have larger space on that can clearly accommodate more processing and more processing throughput. So now with that as kind of background, I'm going to transition into what we're really doing. But I want to first talk about the challenges associated with transitioning technology and really putting it into a production environment. And so, when we looked at this and we started to really look at how we effectively transition the work that the S&T community has done, the joint multi-role tech demonstrators, the joint common architecture, the modular systems architecture demonstration, right? All of this work that was going on, the critical aspect that I really focused on is how do we effectively transition these technologies and how do we move those into that production environment, understanding that production is really a much more complex, as you see, socio-technical system. And you can see the areas that are listed around it, but I think we have the technology. It is, do we have the people and the trained folks to go do this? Is the culture of the organization set that we internally to the PEO, but at the OSD level and at industry have a culture that looks across systems as opposed to our old way of thinking, which is platform by platform by platform. How do we put the right processes in place to do that? How do we have the right governance? And then what is the infrastructure requirements that is necessary? And so, as you know, you've probably read beforehand, right? If you've ever read the book, The Innovators, right? One of the things they talk about is you got to have that great idea. You've got to have the engineering know-how, but then you have to have that business savvy. And they talk about the moxie to make it happen. And so how do we merge those together so that we operationalize the work that's been done and we translate that through into program execution and into the life cycle sustainment of these aircraft? And so with that and taking a look at that, what we realized is that from a PEO perspective, General Berry really had to sponsor and shepherd this through at the enterprise level, because at a project office level, the scope was too great to go do. And so what he commissioned me to do was set up a MOSA transformation office, and we have established that since October in the PEO. We've called on all of the people from across the PEO that really have expertise in this area. And what I want to walk you through is what we are doing within that MOSA transformation office and how that really aligns to creating an operationalized MOSA approach for Army aviation and really for our Army, and how that nests into the work that's going on the ground side as well. So when you look at our specific MOSA objectives, right, lots of words on this chart, but 3 columns, and I want to focus on one specific area in each column. And the first one is the desire, the design to achieve outcomes, right? So MOSA is not in and of itself anything unless it creates the outcomes that we want. But we know while we want it to be more effective and efficient, it is really about how do we create a credible approach for industry? How do we bring industry into this? And how do they see a business model that is sustainable? How does industry close the business case so that industry wants to invest in this approach, sees the opportunity there, will continue to invest appropriate IRAD in it, and feels that there is sufficient return and cash flow to stay in that market space and continue to operate? And so we have looked long and hard on that. And part of talking to groups like this is to further enhance that industry collaboration and really talking beyond the tech and beyond the engineering to how we turn it into an operational business model that provides advantages for industry and for your business case as you go forward. In the center, really affordability, reliability, what General Berry talks about is really, we want to build a capability once. If we build a software functionality, we've decomposed down to the functional level. How do we look at building that once and it cuts across multiple platforms? And so that is really the key in how we can reduce what I will say developmental times, schedule pressure that we have, and the supply chain risk that is incurred in that as we have all of these different products. And then as you look over at the right, I want to focus really on total life cycle affordability, because what we've seen as we've gone in and we've really looked at this is that in many cases, the upfront investment may be larger than if you designed a purpose built. However, when you run the totality of the government and our business case, if you will, what you see is clear advantage from a life cycle affordability. And so we are focused on that life cycle affordability approach that gives us clear return across the total time and the number of software drops and software development we have to do, not just the early development of a system, because we realize it's a continuous process. But then we have to look at how that also plays into industry. And I'll circle back to where I started which was that credible model with industry, that business model with industry. So with that on goals and objectives, I want to talk about what we are specifically doing on our MOSA transformation team and these 9 lines of effort that you see in the center. And really you see that kind of banner that's down at the bottom, which is how are we ready to catch, right? And that's the phrase that I use, right? Is that, you know, the folks that are out working like Alex and what Dr. Lewis started, where you're looking at both SOSA and FACE and AADL and ACTIV, and the work that's going on all of these other programs, and on the ground side in Victory as well, and what CMOS is, which is one of the ground programs, right? How from an acquisition perspective, as they transition this across, right, that well understood valley of death, how do we ensure we are able to catch this and then move it into the future state that we want to create? And so what we went out and did, and when we stood up this MOSA transformation office is dedicated to folks, and we took all of this out of HIDE, which indicates the priority that it has within the PEO. And so when you look at those, I'm going to describe those in a little bit of detail, but really would love to have a more robust discussion. And so I would encourage you that if you want to follow up with me, with our office, certainly we are ready to have these conversations. But first is governance and policy. So we can do many, many things, but unless we have the right governance and policy that drives behavior both within the PEO and then within industry, we recognize that this will not come to fruition. And so we are focused on how do we set up that governance body? How does that cut across the aviation enterprise and the Army, and then the associated policies that quite honestly, in some cases will mandate the design approach that you will use and the opportunities, whether it is reuse or whether or not it is the common use of a digital backbone, or even down to for our enduring systems, do we want to mandate certain things on the way that we look at the embedded systems for mission processing, a mission processor, and then how we would get that up into a crew display via something like ARINC 661. And so those governance and policy is absolutely critical, because even if we have number 2, which are the well-defined architecture and standards, we don't feel that that is sufficient in order to carry this through. And so the first line of effort and what we're really focused on is getting the governance and policy right. I think all of you understand better than I do the challenge associated with good architecture and standards and where you draw the boundaries for major system components. How much decomposition do we need to do, where we actually define key interfaces, where we draw those, and what is, I will call it the sweet spot, because there's a point where it becomes unmanageable. And we certainly understand that we need to be very judicious in how we do that. And we are looking for industry input in that through the work that we're doing through the Architecture Collaborative Working Group, as well as the work that's going on in the Integrated Mission Equipment S&T demonstration that's going on, and some other things that I'll talk about as we move forward. Software development. What do we see as our software factory, our software pipeline as we move to the future? And then really in that software development is how do we bring in the specific modules that we have and provide the opportunity to reuse those, because we've got the right environment that facilitates not only the development of certain software applications, CSCIs, if you want to call it, but then how does it fit into the way that that is within the integration framework, and then the reuse of those across multiple different mission processors, platforms that we have out there. The collaborative digital environment, I'll expand on that a little bit more, but that is really where we transition into a full digital engineering environment, where we move from that SysML and then have the appropriate digital tool chain with the appropriate team cloud and the enterprise level support to go do that. And key to that, and key to the software development as well, are the integrated training programs that we are standing up as well, because we recognize that the training on this is more critical than simply instantiating an environment that allows us to use these digital tools that are now available, and we are integrating into the way that we operate. The next, the MOSA Conformance Center. So we spent a lot of time and effort thinking, and this really ties into when you look at AADL and you look at ACTIV, is how do we measure conformance with the rule sets and the architecture that we want? And so, if we are looking for things that are shall we say, they're loosely coupled or low coupling, but they have high coherence, or we develop a software architecture, we have what we believe is a good design approach to that. We send it out to industry, we get a much more detailed software architecture back, is how do we really evaluate that and look at it? And certainly that is a lot of the work that Alex has been doing, and how we see both AADL as a design language, and then obviously the virtual integration process as being able to really nest between that architecture and standards, the software development, and the collaborative digital environment, and then how we look at it. And when we say center, the one thing that I would say is don't think of that as a physical center. I mean, I think of that as a virtual center where it is everything from reviews of, I would say, some automation that is integrated into a SysML model that would allow us to make sure that we have the right design approach and architecture to it, all the way through that we can validate a software architecture before we go out and start to develop specific code for it. And because I think one of the things that I have learned over in the MRDEC is it is the software architecture that is more critical than the code that is written underneath it. And I say that because somebody could challenge me on some of that. I know not just enough in this area because of the folks that I get to collaborate with to be dangerous. But I am a little bit thin when it comes to diving deeply into all of the technical roots of this. Qualification of material release is another key aspect, and we're working very closely with the Army's Airworthiness Qualification Center and their leadership there, Mr. Keith Darrow, because he too recognizes that there is a training aspect that must go on within our airworthiness certification counterparts. How do we ensure they're trained on these digital approaches, that they can do a requirements trace, that they can do a fault tree analysis through a digital tool, and then how can they look at the software development, particularly if we are using tools like ACTIP and AADL, and then we use, if we use something like SCADE, we auto-generate code, then how can we validate that code and really the architecture in these virtual environments, and then speed the qualification process. And then this also leads into the way that the Army does material release. A $40 billion savings I've really hit on beforehand, and this is where we really are looking to industry to provide us great feedback on how do we close the business case. So we see a clear manner by which we, internal to the Army, can look at the spend that we have across multiple different platforms and how we align that spend and can be much more efficient and effective with that spend. The question is, as we turn into that, then what we've got to make sure is that we have the ability to incentivize industry appropriately. Contract efficiencies go along with that. If we go into a model-based approach, that's part of what I've been talking to Mr. Joe Junta about, who's the head of Army Contracting Command for Redstone. And in that conversation, how do we make sure that the contracting teams have the right training? They understand what open systems are, what are effective contract vehicles to use that, but then how do we convey models, evaluate models as part of source selection now, as opposed to really the paper way that we are still doing it, because we really have to transition into where these tools that we now have fully integrate into the way that we evaluate the conformance of a design, the cohesiveness of a design, and really the benefits of those designs as we move forward. And then lastly, over on the right, what our expectation is out of this and why we've taken this enterprise level approach is that it creates this future state of an integrated, aligned, and synchronized aviation fleet. And when you see that, you see the future fleet at the top, you see the enduring fleet at the bottom, and what you see is a clear alignment between those two, and that modular open systems approaches will blend between those two. They are critical to the future fleet, and we will integrate those in as we have to deal with obsolescence and targeted modernization on the enduring fleet. So naturally, because this is a government organization, I had to put in a wiring diagram, but I wanted to put it in, not to go through this in detail because I really talked about it, but really the focus that we have across the enterprise. And so you see the steering committee. The steering committee is led by General Berrien, and it represents all of the elements from across the aviation enterprise, the future vertical of CFT, the Aviation Center of Excellence, which involves General Francis down at Fort Rucker, AMCOM on our sustainment side, so that we talk software sustainment, the special operations community, the contracting community, and obviously the S&T community and the qualification community. And then down underneath those 9 lines of effort, what I'll highlight is really the 3 areas. So when I talk to folks, and I don't go through all 9, it's really how do we have an enterprise-wide governance approach with architecture and standards, and we understand how to measure conformance. How do we maximize the competitive environment? Because we want to attract OEMs, we want to attract MSIs, right? Mission system integrators. We want to attract third and fourth party software application folks who deal with embedded systems. And we want to make sure that they have the opportunity to really operate in this space, compete within this space, and we don't make the barrier to entry too high, which means what collaborative tools do we need to flow out that we can actually give industry access to? Because while an OEM and an MSI may have them, a third or fourth party may not. And so if we leverage something like a DI2E environment, how does that translate over to the way that we can use that as a collaborative tool with third and fourth party integrators? And then lastly is really the business contracting strategy associated with that and the strategic communications. And that's really about defining the government industry relationships. And really when I say the government industry relationships, it's also how we communicate this back onto the Hill as well, because this is a very different approach from the way that we typically appropriate money, but it is absolutely critical. And so that's part of those strategic communications and part of what we want industry to be able to convey back in as well. All right, so with that, I'm going to transition into a couple more slides where I'm going to dig into a little bit more detail. And again, really reusing some of the information that Alex has provided in the past, right? And so when you look at this and you look at the design language, the one thing that I really just wanted to highlight from this is that as you see this filling the modeling and analysis gap for cyber physical systems, is that we're really focused on how we can ensure we're not air gapping between this chain. So if I start in SysML, I go down into AADL, and then I transition into how I get that into some, if it's DevSecOps for my software or Agile development, the Agile tool Jira or whatever I'm going to use, or if I'm down at SCADE, how do I make sure that I don't air gap those where I have to take information out of one system, put it in, and I introduce the probability of errors that are associated with it. And so, I've used the word kind of a cohesive and aligned approach, but what we're really looking for both from industry, and we recently set something out to industry, is how do we ensure that we understand this digital tool chain that is represented on this? And is it one tool? Is it many tools? We think there's an array that needs to be used, and we're looking for that feedback. And then lastly, just really on the developmental environment, right? So we do see a merging, and we are trying to stand up, right? When you see this CATIA, the digital engineering on MBSE, the integrated software environment that we have for development, and then this verification environment that we need. And so while it says conformance, it really is the merging of those three together. And that is what we're working forward on. And we are making sure that we have that with the appropriate training and governance that's associated with it. So with that is just another quick overview of what I consider to be two key elements, which is, again, that environment or infrastructure, and then the digital tool chain and ensuring we don't air gap it. I'm going to go to really a wrap-up slide that I've got, which really talks about some of the efforts. So I really just want you to focus on the bold, and I'm not going to read it through, but we do have a draft governance and policy. We are going to flow that out through a number of means to get industry feedback. We've defined some major system components. We refer to those as the crown jewels. Again, we're looking for industry feedback on those as well. We've established several contracting vehicles. We just sent out a MSI RFI last week. We've gotten a lot of feedback from that. In that, we want to get feedback on what is your tool chain, what's a good software and acquisition approach, and what's a viable business model for that. And then lastly, you see down on the bottom is, and there was a question earlier, this is nested within the Army's larger CMO effort and what we're doing across the board. And so lastly, what are some of the key takeaways? I just want you to understand that we absolutely are aligned with the work that has been done in the S&T community. We are committed as we move to the future to instantiating open system approaches, and industry collaboration is absolutely essential and vital to this. And when I say industry, it really is academia, industry, us as a program office in the S&T community government, working hand in hand and understanding how to take this from where it is and putting it into that operationalized environment. So with that, I know we are up to the time for some questions, and I will pause for questions to come in and be prepared to answer. And I look forward to the exchange.
Thank you, Pat. This is Robert Conway with the Software Engineering Institute. I want to thank you again, Pat, for your keynote that really opened the entire two-day user experience here. I think you did a tremendous job of laying the foundation for us and for all the speakers that come after us. We do have a couple of questions from the audience I'd like to pose. One comes in, Pat, how do you envision the architecture-centric virtual integration process being implemented by industry? Will there be an established or required infrastructure or some type of connectivity from that?
Yeah, thanks, Rob. I appreciate it. And so how do we see that? That's actually one of the tasks that the MOSA Transformation Office is working on right now when we look at the instantiation of all of, I will call it the tool chain. And so while I don't have a specific answer for you, I think that somebody like Alex Boydston has a clear idea on what he wants to go do with that. And what I will tell you is that we have a couple of different proposals on how we want to view this. But first, I want to take that up to senior leaders and get kind of the guidance and the blessing on our approach to going and doing this. But I think the bigger point out of this is for tools that we want to use, and this gets into the contracting side of the house, and that we potentially will mandate to use, how do we effectively provide secure access into those tools? And so it's beyond ACVIP. And it really gets to what I talked about earlier, which is broadening the aperture so that it is not a significant barrier to entry on infrastructure for small, innovative companies that want to provide software applications within this space.
Thank you. Another question is, and I think you touched on this very briefly, how is it that that security is included into the software architecture, such as in software assurance or supply chain assurance?
Yeah, so that again is, and I did not necessarily touch on that, and I know that I believe the speaker from Collins is actually going to talk about security and multi-layered security associated with it. So if you look at some of the programs that we have going on, I know there's a question or there's been a kind of a comment on where we're going on in AMCS, is multi-layer security and how that is enabled through this is a critical part of it. And so within that software development environment, one of the elements that we have in there is the software surety, and then how that is guaranteed throughout really I will say the developmental environment. And it really leads back to the previous one, because you mentioned, I did say, is that in that enabling environment and where we're going to do this, we want to provide those tools out there, but how do we do it in a secure environment? When I say secure environment, is one that has the appropriate credentialing so that we make sure that that we can continue and execute that. And just another example is one of the things that we've been working towards as well is how do we potentially move to a containerized approach, right? So the thought on using software containers is that I could move into an area where I could have a continuous ATO. Does that provide enhanced security for us? And is that something that we want to require in some cases on the use of software containers within our mission processing architecture that we have? Those are still, and part of what we've talked about within this architecture and the reference architecture we put out, and some of the, what I'll say is the rule sets is that, and we're still, I want to say, kind of negotiating through what is the right language. But what I will tell you is we do want to flow that out to industry, get industry and academia comments on it, and then bring it back in before we finalize anything.
Another question, and this is a point you touched on, it's critical to have industry on board with all of these new movements, particularly to open architectures and to moving away from their previous business practices of holding every single thing proprietary. Have you seen indications from industry that they are ready to move to more of an open architecture and away from the proprietary nature of things?
So I mean, what I would say, it's a little bit of a mixed bag, right? I think that there are some companies that have been working somewhat in this space, but it still, remains. And so, I'll break it up is that I think industry and industry leadership is open to this approach, but we're still trying to figure out how to necessarily monetize software when it is abstracted from a box, because the current model is that I have software embedded in a processor. I deliver you a box that clearly is monetized in the selling of that box, and then the sustainment of that box. I have a clear ability to understand what I will say the revenue, but the revenue from it, what the margin is, and then what my cash flow is from that. And if I transition into a software application abstracted from a hardware application, and then I have multiple different software applications there, where is the long time, what I would say is over years ability to work within that space and particularly recoup any type of IRAD. And to give you another detail, because it does tie in, is one of the things we're talking about is if you go into an OTA, other transactional authority, and you expect a 1/3 cost share, but you expect a 5-year cycle time on it, and you expect lower volume, is there really a good return, or is that really a bad investment for somebody to make up front? In which case, the industry expectation would be, I expect a cost plus contract. And so these are the areas that we are continuing to explore. I will tell you, industry is fully engaged in having these discussions with us. And I think there is still much more work to do to make sure that we have a long-term sustainable business model.
Right. You've seen in your military and civilian career, you've been deeply involved in aviation your entire career. So you can give us a kind of unique perspective on this. Just how fundamental do you think this shift is to moving to open architecture? Is this just kind of one more change that we see evolving, or is this something that's really fundamentally a big difference?
Yeah, so that, that's the big one. It was funny because somebody said to me yesterday is, okay, well, is this going to have stand power, or is this, as soon as maybe leadership changes, is it going to move back? I will tell you that what I see across OSD, and it ties into really this CMOA approach, the common mission open architecture, that I think there was something in the chat about it, a real understanding that the platform-centric view that we had in the past really has to shift, because it is no longer simply about the platform. It is about how integrated mission systems and capabilities are spread across that platform and comprise the totality of really your kill chain when you look at what you're trying to go do. And so I would say it is fundamental. One of the challenges associated with it as we move forward is that, and those who deal in the appropriations world, is we appropriate for platforms, we don't appropriate for open systems approaches. And so fundamentally, that's part of the culture change that I talked about, because we buy an Apache, a Black Hawk, a Chinook, a FLRAA, a FARA, a JSF, an F-35. But when you look at it, there is a set of common mission enablers that, quite honestly, we have to leverage. And I think we also have to leverage it because of affordability. And then really the last thing that I would say on it is when you look at threat evolution and the ability of the threat to evolve, we cannot have, particularly for mission systems that should evolve relatively quickly, I'll use aircraft survivability, we have to be much more agile in that development process, integration in the aircraft, qualification, and get it out to the field so we stay ahead of the threat.
And another question here that we'd like to pose to you is, how do you envision MOSA and ACVIB working for legacy systems, line replaceable units on the existing aircraft, the current force?
Yeah, so I would divide that down into two areas where you've got really the platform side of the house, the air vehicle systems, and then you have the mission systems. And so when you look at the platform systems, and you would say whether it's, and I'm going to go to the enduring fleet, an Apache, a Black Hawk, and a Chinook, different rotor, different transmission, different flight control computer. And so really the opportunity is not there on the air vehicle side of the house. But then when you look at the mission system side of the house, the criticality of the integration of evolving waveforms for communication, the ability to put ASE on the aircraft, and then to take that ASE, and if I have a 2-color IR detector, how can I use that for more than specifically threat detection, but potentially a degraded visual environment? How would I integrate in beyond the waveforms, beyond aircraft survivability, new types of mission command that we need to do, and then how that feeds into the displays to provide more real-time situational awareness. Say an unmanned feed or certain one-to-many, I don't want to necessarily call it full autonomy, but when you can do one-to-many control because we've been able to optimize workload. Those spread across those platforms, and there is clear opportunity within that unique mission space because we're talking about 1 or 2 LRUs, and then how we transmit that information to the cockpit. That's really the area that we're targeting when we look at the enduring fleet and we look at those major system components. How do we build those embedded systems or those processors with an open approach so that based on the backplane and Vita 64, I can have multiple different, I will say card stacks that can go in there so that instead of having a separate box, I've now got it on a card. It then can go in there into, the 3U, 6U form factor that I need. And then how do I potentially, deploy that up in a common format to the cockpit, say A-Ring 661. That's where we really see the opportunity. That's where we're really exploring how we would go do that. And we see that as a bridge between the enduring fleet and the future fleet as well. While we also look at the future fleet for electrical, flight control, the other things where there's more opportunity because it is a clean sheet design.
Great. Thank you very much, Pat.
Yeah, well, thanks very much. I really appreciate SEI hosting this. Thanks all to all who are online for everything that you're doing. This is really having tangible impact on Army aviation. And we are working in collaboration with the great team that's out there to ensure that we can move this into an operationalized context and make it a reality for Army aviation. So thanks very much.